Well, if all goes as planned, extreme athlete Felix Baumgartner will leap from the stratosphere into the history books tomorrow. It will be a 5-hour ride to the edge of space, 37 kilometers straight up, then a 5-minute free fall, a date with a terminal velocity, and the chance to be the first skydiver to break the sound barrier. But until he pulls his parachute, Baumgartner's body will be invested with tremendous force. A single wrong move could send him into a bone-shattering spin. So to keep Baumgartner safe, a special suit was designed. It's similar to an astronaut's, meant to withstand extreme conditions. Canadian spacesuit engineer Shane Jacobs spent the last 3 years building the pressurized suit, and he joins us now from his home just outside Boston to talk about the mission and some of the challenges. So, Shane, we hear about these spacesuits, but what is it about this particular suit that is unique, that can meet the challenges of this jump?
Well, as you mentioned, this is a very unique challenge, and there's a lot of unique requirements for this suit. It's really a human-shaped or Felix-shaped, we designed it to his dimensions, pressurized space capsule. So it protects him from really a lot of perils of high altitude. Obviously, up at the altitude that he's going to be jumping from, 120,000 feet, he'll be above over 99% of the atmosphere, so there's no oxygen to breathe. So this suit will provide him the oxygen he needs. It will protect him from the dangers of high altitude. And we also had to design in some extra mobility into it so that he could roll aside that big acrylic door, step onto that step and look down at the entire world. And then we had to design it so that he could achieve the delta position, which is the position that skydivers like to obtain, so that he can maintain his stability and ultimately, we hope, break the sound barrier as he free falls from that altitude.
So it does sound like this is a fairly high-tech suit that has to do all sorts of things to protect Baumgartner. What's the suit, what's the fabric used in the suit, and how heavy is it?
So you're right, there's a lot of really advanced technology in this suit. It's really the state-of-the-art of pressure suit technology. There's so many different materials and different layers in the suit. To give you just a couple examples, in the helmet, it's really a very advanced technology helmet. We embedded a very thin, nearly invisible wire into the visor so that it will prevent the visor from fogging. And in the suit itself, it's got a layer that is both completely airtight, but also breathable to water vapor. And this is a really advanced technology that really reduces his thermal burden and allows him to maintain his comfort, whether he's in extreme cold or extreme heat. The suit is also air conditioned. He has his own little system where he can control the airflow, and we designed vents into the suit and into the extremities to help reduce moisture buildup. And then the torso of the suit, we use a special David Clark original link net material, which allows some pressurized mobility so that he can do those tasks that he needs to do.
And as he's going through this 5-minute free fall of his, does the technology allow you and everyone else on the ground to track every nanosecond? Are you able to adjust and adapt if anything surprising happens?
So we are collecting a lot of data on this mission. He has several sensors on board, and we're collecting everything from physiological data, GPS that we can track him. He's got several cameras that we designed into the suit that are looking at him and watching him as he free falls. There's also multiple cameras on the capsule that will watch him as he jumps and as he free falls. As far as systems designed, should something occur, we have tried to consider all sorts of potential contingencies and design systems to account for that. One of the most dangerous things that skydivers have to worry about is going into a flat spin, and this can create G-forces that could make you unconscious. When he's jumping from such high altitude, even though he's a very experienced skydiver and he knows how to position his body when he normally skydives from low altitudes, the atmosphere is so thin that there isn't enough atmospheric drag to really push against to control your body. And so this is one of the biggest dangers. What Joe Kittinger did when he jumped over 50 years ago is he used a drogue chute, which is a small parachute that can stabilize yourself to ensure you don't go into a flat spin. Felix, and for this mission, we didn't want to nominally deploy a drogue chute because we want him to be able to hopefully break the speed of sound. But should he not be able to control his body position, we have a system that he wears on his wrist that measures G-forces, and if the G's build up for a great amount of time, it will automatically deploy the drogue chute, which will stabilize him and ensure that the mission is successful. So there's several systems like that that account for any contingencies.
So we know Joe Kittinger actually, as you say, he's done it before. He must be providing invaluable consultation. I know he's part of the Baumgartner team here. So for you, Shane, I mean, you know, everybody's worked hard to consider every possible scenario to make this work, to track it and develop, you know, harness as much technology as you can. What worries you most? What keeps you up at nights before this jump is made?
Well, that's a good question. I mean, there are definitely a lot of risks, and for me personally, you know, I'm a big believer that, you know, for the human race to explore and continue to push our boundaries, you know, we have to do risky things. You know, when this first sailed across the ocean, that was risky, and when we first sent humans to the moon, that was extremely risky, and I'm not saying that this mission is at the same level of those achievements, but it's by pushing ourselves and taking on these risky things and pushing the envelope of human capability that we really learn a lot. For this mission, as a spacesuit designer, I'm really excited to learn a lot about the suit capabilities for high-altitude bailout. As we start to embark on a more human commercial spaceflight industry, people are very curious, and myself, I'm very curious about what would happen if people needed to bail out at high altitudes, and would they be able to survive a free fall like this in the type of equipment that we've designed for this mission. So this is really going to prove out our technology, prove out our equipment, collect the data we need, and hopefully develop a lot of the medical protocols and the spacesuit engineering protocols to enable that future industry.
You know, I get a huge kick out of the words you're choosing. They're all very positive and optimistic, and you're not going there. You're not going to tell me what worries you, and I get that. You probably don't want to jinx things, but let's talk about then the biggest challenge. Will everyone on the ground, part of the team, be holding their breath when Baumgartner breaks through the sound barrier?
I think it's going to be a very exciting moment. We've done analysis, we've modeled things, and we've done really a great, you know, the Red Bull Stratos team has done a great job of working through a whole series of tests. So he jumped from 71,000 feet back in March, and then from 97,000 feet in July, and each time he's been accelerating faster and faster, jumping from higher altitudes, proving out the technology. He yet hasn't broken the sound barrier, and as much analysis and testing as we've done, no one has ever done that. So yes, I think that will be a very exciting moment. All our analysis and testing shows that he will survive and everything will be fine. When he breaks that speed of sound, the atmosphere is going to be so thin that the shock waves will be very weak. And so it wouldn't be like breaking the speed of sound here in one atmosphere. And then as he starts to enter the thicker atmosphere, he'll slow down gradually. So there really isn't this all of a sudden huge break point where he all of a sudden goes something extreme.
You know, Shane, before I let you go, I just have to ask you, of course, Mother Nature, you know, has her own plan. What does the forecast look like for tomorrow? So far, all systems go?
So far, all systems go, yep. Roswell, New Mexico, where we're launching out of, is the best place to launch these types of balloons. Of course, weather, though, is always difficult to predict, so we're hoping that the winds need to be very, very low, essentially zero, just under 2 or 3 miles per hour, and they have to be low all the way up through the atmosphere in different levels. So we're all hopeful that he'll be able to perform it successfully tomorrow.
Okay, we'll all be watching. Shane, great to talk to you. Thanks so much for sharing your impressions, thoughts, and all your own optimism with us today.
Thank you very much. It's been a pleasure.